we've got some AWSers up here and some non-AWS. I'm going to let them introduce themselves. So if we could just go down the row, starting with Julian here, and we'll go over to Emily. That's you.
Hello, everybody. My name's Julian. I'm a developer advocate, work with Serverless. Eric and I are on the same team, so I'm the most unbelievable lucky one, other than Eric's wife. I listen to his yawls all the time. Building serverless applications.
I can hear you.
Are you here?
Yes, I'm here. So, yep.
Yeah, so work on serverless applications. Love the two parts to my job is helping people to understand how some of our serverless things work, and then we work very closely with the product teams, hearing from all of you and bashing their doors down and saying, can you sort this out or improve this or fix this or make this even better or come out with this? And yeah, that's the cool two parts of my job.
All right.
Hi, so I'm Anahit. I'm not from AWS. I'm a lead cloud software engineer from Finland, from a company called Solita. And well, I code, though my managers think that I'm just writing, PowerPoint presentations with pretty pictures, but no, when I do them, I have to code them as well. So, and I'm also an AWS data hero, which is really, really cool. And the coolest part about it is I can go and vent to the AWS people and nag them about their services not working properly. I love it. So yeah, that's me.
Yeah, I'm Alex DeBrie. I'm also an AWS data hero, so that's how I met Anahit and a lot of these folks up here. I am an independent consultant, so I do a lot of work with DynamoDB, with Serverless. I sort of fell into Serverless with my previous job. I was working for Serverless Inc., that makes the Serverless framework, and just got involved in this community, really liked it, and have just been hanging around here for a couple of years now.
Cool. Hi, I'm Michael. I'm a product manager at AWS in the Application Integrations Group, which is EventBridge and Step Functions. I'm not a hero, just a normal guy, and I really, appreciate everyone coming out and also staying on until this time so late. So big shout out to the crowd again. Thank you.
So I'm Gillian, and I do work for AWS. I'm a solutions architect in our Generative AI Solutions Lab. Before I came to AWS, I was an AWS customer for a long time. You did work with Dave, if you heard him earlier. Did a lot of work in serverless, some applied AI. I was a AWS machine learning hero, and they make you give it up when you're an employee, so just regular now. So.
And my name is Emily Shea. So I am the head of serverless go-to-market at AWS. So I lead a team of serverless specialists that works with the AWS field and also some of our largest customers to help them adopt serverless and build serverless applications.
All right, thank you. Michael, you are a hero. I mean, really honest. Michael is it Michael or Mike? Which do you prefer?
Whatever you prefer.
Okay. So Bob, he works for he's a print manager, product manager for the product. And when I first started AWS and I got to meet some of the product managers, like these are the folks building it. They're driving, they listen to us and they drive it, and so you are a hero to me, so there you go.
Well, Michael, what was the last feature that you were involved in that people can praise you for or blame you?
Kafka integrations, Kafka support.
There you go.
Boo!
Yeah, there you go. So, there you go. All right. Okay, so we've had, I have some questions for y'all. So we'll get started. We're going to start with some softballs, and then we'll get into some other ones coming in. And we don't all have to answer it, so we'll go through this. But I'll start. I am going to start down with Emily, I think, and you're welcome to pass or not. But it says, I want to ask, how did you get started in EDA, and what is the biggest advantage of EDA that keeps you here?
Oh, good one. So I guess I really got into EDA in a prior role. So before I was doing what I'm doing now, I was doing go-to-market specifically for EventBridge. And so obviously EventBridge is at the heart of a lot of our event-driven architectures. And I think that some of the coolest things about EDA for me is when I talk to customers and they talk about how much faster their development teams are able to build and how they're able to work on an application and deploy new changes and make small iterations constantly without feeling like they're stepping on the toes of another development team. I think that that's a really common challenge in organizations when you've got a load of different development teams that are working on a large application. And so the ability to kind of move fast and really empower the developers is super cool and makes me very excited about all things event-driven.
All right. Okay. Michael, you want to go on that one?
Yeah. So for me, I can actually pinpoint it to 2015. Back then, I was working a lot. Well, I was actually starting to work with Kubernetes. And a lot of people don't know Kubernetes in that space, but it's inherently event-driven. And so the more I dove into Kubernetes, how it works, I was just curious. I learned that it's like fully event-driven, which is not a promise of Kubernetes, but it kind of, without the events in Kubernetes, it would actually not work and have become the platform that it is today. So that was 2015, and just from Kubernetes, you can already see what it unlocked. And without an EDA architecture in that, it would not have been possible.
Nice. All right. Alex.
Yeah, sure. I would say probably my first tech job, I was a data engineer for like a sports software company, and we were doing a bunch of like internal analytics stuff and building out their Redshift. And we noticed they had like this really deep or like rich event logging of all this stuff, and they were using that for internal analytics. And we thought it'd be cool to like take those and make Kafka, or like make events out of them, publish them to Kafka, and like build something. We ended up like doing that, building a recommendation system. So we like sort of like, I don't know, like retrofitted this event-driven architecture on the thing. I didn't even know what event-driven really was. I was like kind of learning about Kafka at the time. So thinking about that was like really the first step. And then I got into serverless, and like the way Lambda works, I think sort of pushes you towards thinking about it and like makes a lot of those things easier. So I went deeper there. But just like when you asked that question, I was like, oh, you know what? It was when we built that recommendations thing with like this Kafka event pipeline type thing.
So it was your accidental EDA.
It really was, yeah.
Nice.
Yeah.
Okay.
You
All right.
didn't boo when he said Kafka 3 times.
Did you boo?
We will discuss it later.
Okay. All right. Okay.
Heroes stick together.
Yeah.
Exactly.
Okay. Anahit, do you want to?
Well, it's actually a very similar story. Maybe that's why I didn't.
Yeah.
Kafka?
But no. But we'll get there. But I think for me, the most important thing there was the background of actually developing, monolith Java applications, single, huge piece of software, maintaining it for years and years, implementing new features, which was a pain. And when it comes to scaling, I mean, if any of you have done that, you would know that with things like traditional MySQL databases, there comes this inflection point, a magical number of requests after which just everything hits the wall. And then you are there just like, oh my God, how do I scale this? And yeah, I have been struggling with that a lot for a long time. And then at some point when I jumped over this wonderful, as I speak in my talks, to this wonderful world of the cloud, and then I actually had a similar story as Alex, working for a broadcasting company and also having this Redshift and data coming in, and then we came up with this additional event pipeline that we can implement with services like Kinesis Analytics, which was a super cool service. I know it's not that maintained anymore, but let's not go there. So we just basically, without having to touch the main architecture, we were able to just attach this or create these new pieces of software that created value and recommendation engines and things like that, which just blew my mind. And I'm like, what do you mean this is not gonna fail when there's gonna be more requests, So it was kind of a mental shift for me, and I think it hit so hard, in a sense the difference was so big. I was like, I'm sticking to this thing. So yeah, that's my story.
Gillian, I'm going to come back to you actually.
Yeah. So I can date it back to 2015 as well. I was telling Maria earlier. So the very first, people have been talking about microservices and all these new things. They were just coming in, and people were talking more and more about them. And we were starting to use microservices working in internal products. We had a little bit more leeway and using like cool new tech, and we liked the shiny things. And I went to GOTO Amsterdam. And one of the talks, a guy talked about event-driven architecture, and it like blew my mind. And I was like, this is what microservices are for. And then I was like, also this looks really complicated, and I don't know how to do this, but I feel like this is the future.
Did you have that feeling of, do other people know about this?
Did I invent this?
Yeah. So I was like, this is definitely going to be something, but how do we actually do this? So obviously came back and probably built a whole pile of systems completely wrong and learned the hard way over and over until we kind of got it in the right places and doing it the right way. But yeah, way back to 2015 GOTO conference and a talk where I was like, I finally understand what people are talking about. I get this now.
Excellent. All right. Julian?
I probably discovered event-driven architectures without discovering it, without realizing what I was doing in the sort of mists of time. I remember writing some code, probably even decades ago, of something did something and it dropped a file in a file store, and then having some watcher process that would pick up that file and do something. And although that wasn't cloud, it wasn't anything, it was sort of event-driven. If you think of the examples we got with S3, that was the example. And then I used to do a bunch of work with VMware, and we used to have a process that when a virtual machine came up, we would run a PowerShell script that would add some tags into a CMD database. And so this was all event-driven, but I had absolutely no idea this was event-driven or anything like that. And it's weird in retrospect to look back at how many things were event-driven, but obviously cloud and serverless makes that so much more applicable. But for a more practical recent example, hopefully people had a good coffee at Serverless Espresso, but our whole team, even Dave used to be part of our team, built Serverless Espresso, and one of the cool things that happened as part of it is we were all brainstorming ideas and thinking about what we were going to do. And we had obviously the idea of Event Bus and this kind of thing, and it was like, oh, we need this service. Now, I had come up with an idea with some other people of, well, let's track all the orders that are coming through the service, so when you're finished on your phone, you can look at the timestamp of every event that came through. And it was like, okay, we'll go off and build that, and could completely build it as a separate microservice, didn't have to think or care about what anybody else did. And that was just a way to show how a team could work independently but build the same application using event-driven architecture. So it's sort of two different parts of it, but I think that the team aspect of it is super useful, of just how different teams can work on the same app but in different ways.
All right. Excellent. Okay, so now we're going to climb in a little bit here. So this is from the audience here. I'm going to ask a question, and somebody can step up or step back. All theory hits reality. So we've got some. Yeah, exactly. All right. All theory hits reality. What's the actual % split for systems you manage, support, or advocate for that do run fully EDA? And for the classic designs, what were the arguments for staying with the standard methods? I will pick in a moment. But does anybody have anything they want to throw? All right, Alex?
So I do, this is not going to be a great answer at EDA Day.
I'll let you know.
Okay. So I do a lot of consulting with smaller early stage places generally. And so a lot of them are still working with fairly small monoliths, I would say. And I just think there are a lot of benefits to staying synchronous in a lot of places, or what I call like intentful asynchronous, where you're dropping something into a queue or into a step function, state machine, something like that. But you sort of want a specific thing done where you still have a small team. You don't need all the benefits that you get, but also the added complexity, as David was talking about earlier, from going full EDA on that stuff. So as it gets bigger, you might add in more EDA things when you have lots of teams and it's harder to coordinate a lot of different things. So I'd say like for those smaller applications that I work with, there's not a ton of direct EDA stuff, although there is like some eventing based things around that as well. But sometimes I work with larger customers as well that do some of that, just because otherwise it is harder to move quickly independently.
Yeah, and I think I'd be hard pressed to put an exact percentage on it, but I think every single customer that is doing event-driven architectures definitely has a kind of a balance of different types of approaches, some event-driven and some not. I think that the Gregor Hope has a great quote about kind of the amount of coupling that you want between two systems varies depending on how much control you have over the two systems. So if you are a small company, for example, and you have kind of full control over a small application, it makes a ton of sense to just kind of like like maybe build a monolith or build synchronously because you have full control and understand the system very deeply. Whereas the minute that you're in kind of a much larger organization and you have a development team that sits way the heck over there, and you really don't want to know a ton of information about their system, maybe this is where we see a lot of kind of pairings of an orchestration approach where you have a ton of control. And so maybe within a development team or within a company that's small, you have all of that control with an orchestrated system. But then you would take a choreographed or more event-driven approach when you need to integrate with a system that you fully have no control over, and you really don't want to have to kind of understand a ton about that system. And so you want to use decoupled events to be able to talk to that system. So it definitely varies based on kind of the type of relationship that you have.
I want to maybe add to your point, Emily. First of all, I think it's a bit of a spectrum. I don't think we have this, clear separation with this is fully EDA and this is fully not EDA or classical, traditional, whatever you call it. So I think somebody mentioned today on stage that event-driven architecture has existed for tens of years, and the same Gregor Hopper. We have to send him a message that he was the most quoted person today.
He knows.
But good. So he has written a book about integration patterns, 20 years ago? And so basically service integrations are the early day EDA. And we have been doing that forever, and we are doing that. And I would argue that majority of the software we are all collectively working on has some sort of integration, which probably uses some sort of an event-driven architecture. So I wouldn't go to this percentage of customers only use EDA, and this percentage of customers don't use EDA. That being said, there was also a part of the question that asked they don't. How was it? Why they don't adopt EDA?
Right. So, and for classic designs, what were the arguments for staying with standard?
Yeah. So my experience is, in many cases, it's the resistance from the developers actually to learn or to do things in a different way, especially if it's a team of experienced developers who have certain ways of doing things. Sometimes it can be really hard to break that barrier and say, hey, maybe we should try it in a bit different approach. So that has been, to me, that of course there are organizational level kind of obstacles as well, but that has been one of the bigger things that I've seen. That being said, not many, it doesn't happen many times, and as time goes by and event-driven architectures do become more of a status quo, you can see that people are becoming more and more kind of willing to use it, more of it. But yeah, so I don't know. I didn't answer the question, but that were the thoughts that it kind of provoked.
Yeah, sounded smart.
I also think that it's sometimes sort of change the thinking around that. It's not as though event-driven architectures is necessarily better or improved. It's just a different way of doing it. And sometimes I like to say to people, if your application is working, there's no reason to just change it for fun. Those big ideas of, we need to refactor the code base. We could do this way more efficiently. When your CTO is like, that's not going to add anything to my business. It's going to add risk and all this kind of thing. So only even think about event-driven architectures maybe when you have a problem or you need to add some more functionality or this kind of thing. But like, if your stuff works, leave it alone. Don't get overexcited about changing it to EDA because no one's going to care. So yeah, keep your horses on.
Another thing I would say, you mentioned, or at the beginning of that said, like, hey, when theory meets practice. And I know when I first heard about EDA, or like earlier in my development career, I would be like super purist about whatever like new idea I heard, So like for EDA, I was like, oh man, when you publish an event, you don't care who used it. You don't even know anything about your consumers and all that stuff. And it's like, that can work. But I sort of like, I know like Luke von Donkersgoed has talked about what they do at PostNL, and I'm pretty sure when you subscribe to an event, you sort of have to register that you're subscribed to it. So then if the producer wants to change their event, they know who's depending on it. They can maybe go have a conversation with them rather than just being like, no, it's totally abstracted. I'm just pushing this out into the world and whoever wants to do whatever with it. And it's like, I think finding some of that middle ground of like, hey, we don't have to be totally pure. We don't have to do like command query, CQRS and all that stuff. Like that's cool. That's interesting in certain places. But like, I think finding a balance of like, hey, where can this really help you improve your architecture?
I think it's like so many things. It's the right tool for the right job. Yeah. I mean, and it's cliche and oversimplification, but really half your job is evaluating the right tool for the right job. So so leading in, we have another question that says, EDA architecture red flags. What should ring a bell that we are introducing EDA badly?
I think one is, I might have heard it also in James' talk earlier today, which is if you don't get your module and your boundaries right, even like within the services, but also between the services, where there's a lot of chat going on back and forth after an event has been raised and consumed, that is a red flag that you did not get your module boundaries right. And I would advocate for, like a lot of times we say go microservices, go fine-grained, and we discuss like what is a microservices, how small does it need to be, but to think more about the aggregates. This comes from domain-driven design. I think there's a lot of learnings in domain-driven designs, and one of the key ones, the insight that I found there is the notion of an aggregate, which is the consistency boundary. And if you figure that one out, that gives you strong like transactional semantics for your objects, entities, whatever. Then you got the boundary right. And if not, if you see doing like cross transactions between services or having chats going on back and forth between services, most likely you got the boundaries wrong, and that certainly is a red flag.
Yeah, to add to basically the same vein, if you notice that to make changes in one service, you always have to make changes in the other service, well, that is a huge red flag. That maybe they need to live together, maybe you don't need that EventBridge or whatever wonderful service you have in between.
Yeah. We were. I know I'm not a panelist, but I'm gonna say this anyway, because I was having a discussion, and maybe I don't see him in the room, but we were having a discussion earlier about I have one service doing this and another service doing this, and I'm passing events back and forth, and the question came down to is, do we need this service? Could this service just do that job? Make the call rather than calling over to this to say, hey, go ask it. And so it's really, and at the end of the day, yes, that service is needed for some other things going on. But I think sometimes, and I'm guilty, I'm a purist as well. It's like, no, I can't talk to you because I don't want to know you exist because I'm an EDA person, so please leave the room. But I think sometimes we get too molded in that. However, I would push back on, and I said in my talk earlier, that it's critical to plan for scaling. And even what you were saying is like, look, if it works, it works. And I do believe in that if it works, don't break it. But if it works and you're scaling, then you need to be, if you're, hey, this is load we always have, this is load we've always had, whatever, that's fine. But if you're scaling, if you're not planning for that, that becomes problematic. And I think that's where EDA really starts to become a great answer.
Thank you, moderator.
You're welcome. Yes.
No, I was going to add on as well as I think.
I'm not the moderator. I'm the sound guy.
Oh, of course. Many hats.
Yes.
I was just going to add on that I think that one thing that I also see is just the hope that maybe event-driven architectures you can be 100% decentralized and you can just kind of start emitting events and we'll figure it out as we go. And I do think that there is while you can ultimately get to a decentralized building place where you can all kind of individual teams can build independently, it does require a little bit of kind of foreplanning and also a bit of kind of central thought when it comes to like event schema standardization and how you're going to handle that, or how you're going to handle event schema changes when something needs to be altered in that. And so I think there is a little bit of kind of central thought and central planning that goes into a well-designed event-driven architecture up front.
All right.
I'll add quickly, observability. If you don't know what events are going where and how they're connected to each other, just going to have a world of hurt.
Yeah, I agree. But I can't talk. I'm just kidding. All right, so I have several versions of this question, so I'm going to ask the panel. It's a little off topic, but it's on topic for all of us. This is, in the world of GenAI, okay, how do you see, everybody's passing their mic to Gillian. Here you go, Julian. In the world of GenAI, how do you see, how do you see it affecting the developer's role?
Gen who?
GenAI. Are you making fun of my accent? Yeah, a little bit. Okay, yeah, exactly. Yeah.
I really can't make fun of accent.
Yeah, all right. I know you can't. So anyway, the question is, in the world of GenAI, that's yeah. So how do you see this affecting the developer's role, the development cycle, applications in general? How does it affect our future? Gillian.
Can we answer that? Are you asking like none of us have jobs anymore?
You know, well,
we can all go lie
I
on
would
the
say
beach
maybe that
and,
apocalyptic, you know, yeah. What do you think?
Well, I mean, it's learning from all the code that's out there right now. So if you think about how good the code you've written so far is, that's the standard it's staying at.
Apologize now, Alex.
You're on point.
Yeah.
When I first started developing a million years ago, right, my IDE didn't tell me that I'd missed a semicolon at the end of the line, right? I had to cry to find where you'd missed it. Now my IDE highlights things, it auto-completes things. I mean, there's loads and loads of things that are making it easier to develop. There's lots and lots of tools. A lot of stuff has got automated. Development role hasn't gone away. Because at the end of the day, if you can describe how to solve a problem well enough that a computer can do it exactly, well, then you've written code, realistically.
Yeah.
So you're still going to need to have people who can understand the problem, who can describe it well enough. Even if you're not going to write the actual baseline code, if a system is going to write that for you and you're not going to have to type as much for a while, for sure. You're going to have to do hard work on those prompts we talked about how you have to word things really carefully or you don't know what you'll get. So I do think it's just going to become another tool that developers use, and you're still going to need people who understand how to take, a business problem and translate it into something that a computer can solve for you. I don't know, other opinions?
Yeah.
Same vein, I think I can cut it short with, there was a tweet a year ago that I saw from someone who said, overnight, he got ripped off like 90% of his skills and capabilities and what people were asking him for. And then he was kind of shocked. But then he realized that the remaining 10%, like the creativity, the intelligence, and that made him a human being, got accelerated by times 100, as you were just saying, because we have a tool that makes the daunting tasks easier or disappear, and then allows us to focus on things that are like that we human actually being built and designed for from some bigger entity out there.
I like that. That was good.
I can add, basically we are all saying the same thing, but I think there's this quote, and I don't know whose it is originally, but it's something along
Gregor Hopper, maybe?
No, I think this one, surprisingly, is not by Gregor, but I will ask him. But a quote goes something like, I want the AI to do my laundry and dishes so that I can have time to do art and creative work. And somehow, I mean, it resonates a lot because, and I do understand it perfectly, because a new technology comes in and we try to apply it in every possible way. And we are like, look, it's so cool. It can create images for us. It can compose music for us. It can draw pictures for us. But I would argue that that's probably the original hype of let's try it everywhere and ooh, this is so cool. But the reality of it is that what we actually want is for it to do the stuff that we don't want to do. So basically the same. We want it to help us and to remove that 90% of stuff we don't really like to do, but we have to, and give us more time and more energy to do that 10% that we actually want to do and are good at. And I think Massimo had this wonderful talk where he, at AWS Community DACH in Munich a couple of days ago, and I think the main point was, if I can summarize, I'm not as good as GenAI to summarize, but I will try. So basically, the GenAI tools will help you more, a better professional you are. So if you don't know nothing about, like let's say you are coding and you know nothing about stuff, and then you try to create decent software with GenAI, well, guess what? It's not going to happen, at least not now. And the more you know, the more it can be a helpful tool to you. It can be an assistant. It can help improve your skills. It can actually help you learn more and become better. But for that, you have to be good yourself. So I kind of like to think that way, maybe because it's comforting. I don't know, but that's the way I like to see it at the moment.
There was a recent study where they found that humans are still better at summarizing. So
Maybe not me in particular.
Which
Take them
humans?
longer, but they
Yeah.
write a better summary.
Yeah. Okay. All right. Anybody else want to throw in on that one, or?
I think it's also got cool use case. There's a lot wrong with GenAI. I mean, let's not. I don't want to. Myself on this panel, there's a huge amount of things of, governance and data and feeding the models and all those kind of things. There's just, it is a crazy wild west world out there, and hopefully we will figure that out. But the question about being a software developer and a software engineer, I also think if you're a junior software engineer and you're learning to code and trying to figure things out, it's really hard to do tutorials on a website or do things like that. You get the basics and you sort of figure that out. But if you could take your company's code base and you can right-click and explain this code to me, and a GenAI is literally going to the world's summarization and explain exactly all the methods and all that kind of thing, that is an amazing way to learn how to code, where you've got your own company's information that you can learn. And then, if a GenAI could be clever enough to add a little bit of functionality which you can test, that's a great way for, I think, we talk about GenAI taking the jobs of junior software developers, but I think it's going to accelerate them learning to become senior software developers, even maybe that little bit quicker so they can do the creative stuff. Because coding is only 10% of the work. It's finding the business problem, even articulating what some crazy VP wants, and then the coding's the final part. And
All right.
Yeah, I just want to say I agree. Like, I think junior and seniors use it in totally different ways. I think I see seniors using it to be more productive and just like get a lot of the boilerplate that they don't want to do done quicker. But like as a junior, what an incredible learning tool. Like, you don't even know what you don't know, but now you can ask it why is this web page doing this? Like what CSS element or what is going on to make this like actual effect happen? I know like I'm still bad at front end and I use it all the time to like figure stuff out. Yeah. So I think it's I think it's super useful that way.
Yeah. Okay. All right. Great. So we're coming back. We've had a lot of questions come in. So, all right. I like this. You quote a lot of Gregor Hope and integration patterns. All right. How does the event-driven architecture different from old enterprise service bus architectures? Which aspects of system integrations do you think are going to stay, and which will evolve into something else?
Okay, so I can actually quote Gregor on this one as
yeah,
well.
Nice, good, okay.
Though I think this was the time when he joined AWS that he was like learning our services, and he started building event-driven architectures based on his book actually. So he was trying to understand how much has changed since the 20 years that he wrote the book. And he realized that, in particular around the ESB question that we have a lot of open standards now, open standards that are not governed by one or two big enterprise companies influencing the standards, such as HTTP and JSON, which were not as dominant and didn't even literally exist 20 years ago. And Gregor realized by building these services that he actually built systems, even though he was using AWS services for his exercise, there was no real lock-in in that regard because it was all based on open standards like HTTP and JSON. So he then built another one using GCP. And in fact, it worked. He just had to use the different primitives that existed there. And I think that is a fundamental difference between the old ESB days, which were, I would say, highly proprietary, and you couldn't easily take an application that was built in ESB from company X and use another ESB from company Y. I think that has fundamentally changed.
I think, from my perspective, one of the big items that's really changed and why we're kind of talking about event-driven architectures to such a large extent today is just what's made possible with cloud. One thing that I've heard a lot of folks say is the fact that you used to be able to build an event-driven architecture, but you had to kind of go out and publish the events yourself, build things to consume the event, build things to pull. But now you have so much that is coming out of the box or baked into services. If you think about the amount of just events that are flowing through your AWS services today, in terms of what's going on with instances or coming from step functions, there's just so many events that are being emitted by default. And so that's why I feel like there's plenty of people on the panel that said, I kind of fell into event-driven architectures, or I started using Lambda and then kind of asynchronous and EDA patterns came out of it. It's because that's so baked into the cloud and available out of the box today, whereas it used to be something you had to go out and create fully from scratch yourself, which is very powerful.
Right. That's good. All right. all of a sudden it was like, oh, here's 100. So we're not going to get to all the questions, but I'm going to do the best I can because we're about 5 minutes in. So I'll ask this. This is probably our last question. So it's kind of more of a broad stroke. What do you think is the next big development or innovation in EDA?
I think the thing that I'm most excited about, just kind of continuing in the vein of like what cloud makes possible and where we're at in the kind of journey of event-driven architectures today, is I think that we've seen a lot of kind of advancements. If we think back to the history of kind of cloud and how things are progressing, where you had first just event-driven infrastructure scaling, so the ability to scale up your infrastructure, but maybe those events were more infrastructure events in terms of like, oh, like we need more kind of capacity or whatever else. Whereas now I see a lot of people using business events to scale up their infrastructure, which is a real kind of step change in the amount of the way that you can optimize that, the way you can really optimize your infrastructure based on like event volume and all of those things. But now I think that the next thing that I'm hearing people start to ask, those ones that are really on kind of the cutting edge of EDA and what they're doing in the cloud, is how do I learn more and understand my business better based on the events that are flowing through my application? How do I kind of fine tune like, oh, here's like a hotspot for customers, or how do I kind of make sure I can tweak things and understand where like my revenue is flowing through by looking at my application and looking at the business events flowing through it. So there's some really cool, as we bring kind of like what's going on in the business and what's going in the technology even closer together, there's some really cool insights and more powerful things that we can bring together, which is exciting to me.
I'm going to say something and I'm going to hand over to Michael, so he's going to get ready. I think we've done an amazing job of abstracting a whole bunch of primitives, and we have different services to do those primitives, and I don't think I've quoted Gregor, so just to quote Gregor to be the final one on the panel to do that. Enterprise integrations 20 years ago have all these patterns, and we've codified those patterns into individual services. But we've never actually written it for the cloud. It's all these, I've got to pick a service, it's all got its semantics, do I choose between SNS and EventBridge or SQL, like all the stuff you need to learn. And I think the next evolution is going to be actual programming for the cloud, where you program architecture, you program applications, and the cloud figures out a whole bunch of stuff for you, whether it's services or push or pull or all these kind of semantics. I know Michael's got ideas on this too.
Yeah.
I'll put him on the spot. Sorry.
Which team is releasing something, right?
Yeah. I don't know. I had like 2 months ago, I had an epiphany where we've seen James talking today about observability, like why it's so important for event-driven architectures. Anahit, she talked about embracing failures and the failure modes, the dragons that await you in these distributed architectures. Dave talked about contracts. So while we see there's a lot of benefits in EDAs, there's also a lot of complexity and things that you have to understand and absorb and also educate your teams and developers. And the epiphany that I had was that I always thought about synchronous versus asynchronous. For me, it was like you have to pick one or the other, or sequential versus asynchronous computation. The monolith, the model in the monolith typically is like very sequential, where you see what it's doing, it's the step procedurally, and you know what's going on. There's no concurrency, not necessarily. There's no data races unless you really put them in. Versus in an asynchronous world, an event-driven world, everything is asynchronous, concurrent, and you have to think about transactions and locking and all these kind of things that also Alex today spoke out with Dynamo. And the moment that I had there was, instead of looking at it synchronous versus asynchronous, I was like, what about if it's synchronous on top of asynchronous? So you have a sequential procedural programming model asynchronously executed, but you don't really see that asynchronous fabric. You don't have to work with the primitives that Julian just mentioned, like brokers, queues, and functions. And that is the land of durable executions. It's a promising technology. As a purist, I would say it is the future, but we know that there's no such thing as one technology owning it. But maybe that's something that durable executions can help us with by simplifying the programming model, but still giving us the benefit of EDAs like the asynchrony, the highest scale and reliability if done right.
And we're out of time, but I can you in 30 seconds talk about what that is?
Yeah, it's basically, think about what JavaScript or TypeScript is. It is a programming language which gives you standard procedural logic, But behind the scenes, everything is asynchronously executed on an event loop. That's basically JavaScript in a nutshell. And the event loop is just a queue where the functions, the results are paused and plugged into, and there's a scheduler popping up of this queue, which gives you this nice illusion of a single-threaded sequential programming model. And you don't have to think about asynchrony. Later there were callbacks and all these kind of things, but they evolved into a promise-based system where you await a promise, and this gives you a sequential flow. And durable executions is exactly this, but not that the queue is in memory, but it's persisted like durably behind the scenes, and there's something that pops and invokes you, and there's this asynchronous dance. I hope that was clear. Otherwise, let's talk after.
But I think the power of that is to be able to run that at cloud scale, where you've got unbelievable scalability and all the kind of coolness of the cloud, and particularly serverless behind the scenes, but you don't have to interact with that complexity. Yeah.
And that's basically what you were saying, that we have basically need another level of abstraction that will abstract away all these problems that we were all discussing today, and the complexities and the issues that everybody needs to know, abstract them away, and maybe we don't need to care about them anymore.
Potentially, but it may not also be an abstraction, because an abstraction can hide things, and there may be a way to just program it differently that you don't have to make as many decisions, because sometimes I do worry about abstractions, because the further you go high up, there are abstractions that you do want to care about, and the abstractions you do want to forget about, and so there's a nuance.
So it's interesting, and I'm going to wrap us with this. But there are several
quote from Gregor, I hope.
Well, no quote from Gregor. He quotes me a lot, but everything I make broke. But I don't know. So, there are some companies out there that are taking a whack at what y'all are talking about. I know Winglang is one. Amped is another. Maybe not exactly, but that idea of a language for the cloud. And then it kind of abstracts out. So that's, I agree with this statement that is possible where the future is how much can we abstract that out. I'm the moderator, so I'm going to stop there. But we are at time for that. But now we've got the after party where we get to hang out and talk. But I want to just take a moment for the panel and for the speakers and for us to say, we really appreciate you all coming. We thank you very much. Thank you to our speakers, local and from AWS and who came in. But most importantly, thank you to you for attending. This is fun for us, and we get to learn from you as much as you do from us, probably more, to be honest. With that, I'm going to say thank you again, and I think, Maria, we're set up out here, right?
Sorry, I'm going to just say the last word, that there are three other people I want to call up.
Okay.
Well, not call up, but just recognize. Matt Meckers, who's sitting over there,
yes.
He is logistics king, and he's just organized so many people to be able to come to be part of the community and everything, so good job, Matt. Eric's been loud and opinionated, but he's Eric, and he's literally done a huge amount of organization for the day as well. He's done an awesome job on the AV. I think he did a talk as well, which was quite good. But Eric has done an awesome job. And then lastly, Maria at the back, who's logistics extraordinaire, and she's put everything on. So thank you to all the wider people who've made this today happen.
Thanks, sir.